Hello everyone, welcome once again to our session. Today we are going to continue our discussion on the integration by substitution algebraic functions. Last time we solved this example number 3 and we have tried that when we use the same process as in our first two examples for this topic, we cannot use that method because of this reason that we cannot find the perfect du. No? From this du, we're looking for x cubed dx, but in our process when we look for derivative of u with respect to x and we manipulate the result, we cannot get this x cubed dx. So we can say that x cubed dx is not equal to x dx, which is equal to du over 6. So in this case, we cannot solve this problem using the same method as what we have applied in our first two examples. So last time we used the other method that is still substitution, but we have to use the basic concept in binomial expansion in algebra. So what we did, we just break this up into two factors, the 3x squared minus 2 raised to the power 4. We break this up into two factors, and then we expand its factor. Okay, and then after the expansion, we come up with the result of the expanded expression of this form, and then we substituted this, and then we distribute the integral sign and also the dx in its term of the expansion, and then we integrate the given integral functions individually. Okay, so that was our solution on our third example last time. So today we are going to solve the same problem. So our solution is related to what we have done last time, but this time we will use specifically the Pascal's triangle principle. Okay, so in Pascal's triangle, if we are given this binomial a plus b raised to the power 0, so we can rewrite this as, because we know that any expression or any number raised to a power 0, that is always equal to 1. So we write 1 here to represent this. Then if you have, say, a plus b raised to a power 1, so we just need to write the coefficient of a and b, then put it here. Okay, so this one corresponds to the coefficient of a, and this one is the coefficient of b. So we know that if you have any number or expression, when you raise that to 1, so that is the same number. So it means that if you raise this whole, the sum, the binomial, into 1, so you just obtain a plus b, where the coefficient is 1 for a, 1 for b, and we write it here. Then for this one, a plus b raised to a power 2, of course, so when you expand that one, if you still remember from your algebra, if you have if you expand this one, you have the expansion here is a squared. The first term of the expansion is a square of the first term, then plus twice the product of a and b, then the third term will be square of the second term. Okay, so what I mean is that if you expand this, so this will be a squared plus 2ab, then plus b squared. Okay, so in Pascal's triangle, so this one, the coefficient of a, which is equal to 1, or if you look at the middle is 2. So this 2 here is just the sum, no? The sum of this from the previous 1 plus 1, that is equal to 2, Okay, and then you just put 1 on the left and also 1 on the right. Okay, so 1 here, it corresponds to the coefficient of A. Then 2 here is the coefficient of the product of A and B. And 1 here is the coefficient of B squared. Alright? Then, okay, so I will erase this. So I'll just erase this one, class. So if you have, say, A plus B raised to a power 3, so you just follow the pattern. You just, what you're going to do, you just add, like what we did a while ago, you just add this one, you have 2, then put 1 on the left and the right side. So in this case, you just add 1 and 2, so you have 3. Then when you add 2 and 1, that is also 3. And then you just put 1 on the right and 1 on the left. Okay, and then if you continue this one, if you have, say, A plus B raised to a power 4, so this in Pascal triangle will be something like this. So you just add 1 and 3, so that would be 4. 3 and 3, you add that 1, so that would be 6. 3 and 1, you add, so that is 4. Then again, you just put 1 on the right, on the left, and also 1 on the right. So you see, we form a triangle. Alright, since our exponent of the given function, integral function, is 4, so this is a binomial. Binomial means the expressions that contains 2 terms. So there are 2 terms here, 3x squared, 1 term, another term is 2. Okay, so this is binomial. The power of this binomial is 4. So this one, 4. So we just stop. No, we can stop up to this part, and we have to use this coefficient. So we have to make use of this. Okay, so what is this 1? 1 is just the coefficient of our first term. Okay, so this represent, which is the power 4. Okay, all right, so I will rewrite it. So 1 here is the coefficient of, this is the coefficient of A, because we have A and B here. So our terms here contains only A and B, no, for this particular binomial. So 1 here is just the coefficient of A, where our A is, so A, and then you have 1, so that's the coefficient. And take note that the power of A here is the power of the exponent, or the exponent of the given binomial, which is 4. Okay, and then you have supposedly B here, B, but the power of B is equal to 0. So supposedly you have B to the power 0 there, but any number or any expression raised to power 0 that is equal to 1. So no need to write that one, no, from the binomial expansion theorem. Okay, so next, and take note, class, in our given, so this is plus, right? The sign in the middle of the 2 terms is plus. So expect that the sign here are also all plus, all positive. But since the given is negative, this is minus at the middle of the first and second term, so the sign here will be alternating. We have here positive, then meaning positive, then negative, positive, negative, positive. So that would be the sign of its term in the expansion. Okay, so next we have 4. So 4, the coefficient 4, this is the coefficient of A. Okay, so as mentioned, since this is negative, so you have the sign negative here. So this is 4. Okay, this is the 4. Then A, and the power of A now is 1 less than this. So we have the first A here, the power is 4. So the next power is 3. Alright, and now you have B. So the B here has the power 1. So take note, class, that the power of A here is decreasing and the power of B is increasing. So this is power 1, so you don't have to write 1 because that is understood to be power equal to 1. Okay? Then next, so the next sign will be positive. Okay, so this will be positive. So this is plus. Okay, then you have 6. So again, 6 is the coefficient of A and B. So our A here, then we have B. So this time, class, as mentioned, that the exponent of A will be decreasing. So we have 4, 3, and this becomes 2. Then we have, so B, we have originally 0, then 1, then 2. So this will be 2. Then next sign will be minus. Okay, so minus. Then we have 4. 4 is the coefficient, again, the coefficient of A and B. Alright, so A, then we have B. But the power now of A, or the exponent of A, becomes 1. So you don't have to write that 1. And the power or exponent of B is equal to 3. Then next is we have plus. Okay, plus. Then 1 here is the coefficient of B. And B now has the power equal to 4. Okay, so supposedly there's an A here, A to the power 0. But you don't have to write that because A to the power 0, that is equal to 1. Alright? So this is B. So rewriting it, so this will be A to the power 4. A to the power 4 minus 4A cubed B. Then plus 6A squared B squared minus 4A B cubed. Then plus 1 times B is B. So B to the power 4. Okay, so that is now the resulting expansion based on this given exponent equal to 4. So we use this one. And this is the expansion that we are going to use to expand this. And from here, we can let our A equal to 3x squared. Then our B equal to 2. Okay, so substituting. So I will write it here. The expansion of 3x squared minus 4 raised to a power 4 is simply equal to, you just copy this one, A to the power 4. Okay, so but our A is equal to 3x squared, then raised to a power 4. Okay, so that is our A. Then minus, you have 4A, our A is 3x squared, then raised to a power 3. Then times B, where B is equal to 2. Then plus 6 times A, where A is 3x squared, then raised to a power 2. Then times 2, then squared. Then minus 4 times A, where A is 3x squared, times B, where B is equal to 2, then power 3. Then plus our B is equal to 2, so 2 to the power 4. Okay, so this is the equivalent expansion for this one. Then using the law of exponents. So we can rewrite this as you have to, from the law of exponent, you have to raise each of the factors here with this exponent. So we have 3 to the power 4, that is 81. Then x squared raised to the power 4, that is equal to 8. Then minus, we have 4. So 4 times, we have 3 here. 3 raised to the power 3, 27. 27 times 4, then you have to times 2. So what is the result? So that is equivalent to 216. Then x to the power, you have x squared raised to the power 3, so you just multiply this one, so that is equal to 6, the power is 6. Then plus this one, you have 3 squared. 3 squared is 9 times 6, 54 times 4, because 2 squared 4. So we have also 216 or 216 times x to the power 2 times 2, that is equal to 4. Then minus, so this one, you have 4 times 2 to the power 3. What is 2 to the power 3? So 2 to the power 3 is 8, right? Is it correct? Let me check. So 2 squared, okay, 216 is okay. Okay, so this is 4 times 3, 12. 12 times 8, so that is equal to 96. So 96 x to the power 2, then plus 2 to the power 4 is equal to 16. Okay, so this is the equivalent expansion of this. So now let us rewrite this one. So from here, from the given, okay, so I will write it here. So equals the integral of 3x to the power 2, then minus 2 to the power 4, then x cubed times dx. This is equal to, so instead of writing this, you just write this expansion. So that is equal to, so of course you copy this integral sign, so you have integral of, so write all this because this one is equivalent to this one. So 81 x to the power 8, then you distribute x cubed dx. So this one times x cubed dx, then minus integral of 216 x to the 6, then multiplied by x cubed dx, then plus integral of 216 x to the 4th power multiplied by x cubed, okay, put this in parentheses, x cubed dx, then minus integral of 96 x squared multiplied by x cubed dx, then plus integral of 16 x cubed dx. Okay, so I hope you're able to follow, class. So this is equal to, then isolate the constant, put the constant outside the integral sign. So 81 times the integral of, sorry, this is 81 times the integral of x to the 8 times x to the power 3. So you just add the exponents, so that is 11 dx, then minus 216 integral of x to the 6 times x to the 3, so that is x to the 9 dx, then plus 216 integral of, so this is x to the power 4, then you have power 3, so that is x to the 7 dx, then minus 96 integral of x to the power, you have 2, then you have 3, so that is 5 dx, then plus 16 integral of x cubed dx. Okay, next, applying the formula. So our formula is the general power formula. So this is equal to 81. So applying the formula, so this will be x to the 12 divided by 12, then minus 216 x to the 10 divided by 10, then plus 216 x to the 8 divided by 8, then minus 96 x to the 6 divided by 6, plus 16 x to the 4 divided by 4 plus c. Okay, so if you evaluate this, you have 81 and 12, so you cannot divide 81 by 12, so you just find the common factors. So 81 is divisible by 3, 12 divisible by 3, so 81 divided by 3, that is 27. So we have 27 divided by 3 x to the 12, then minus, so this is divisible, this is not divisible by 10 but divisible by 2, so we have divide by 2, so this is 108 divided by 5, so divide by 2, divide by 2, x to the 10, then plus 216 divided by 8, so this is divisible by 8, so that is 27, so 27 x to the 8, then minus 96 divided by 6, so this is divisible by 6, and that is equal to 16 x to the 6, then plus 16 divided by 4 is 4, so x to the 4th, then plus c. So this is our answer. Okay, so I hope you were able to follow class. I hope you have seen it. Okay, so that's it. If you compare this with our solution in the previous video, okay, so you see here, so this is the solution of our previous video. So they're just the same, right? So we have here 24. Sorry, this is over 4 class. I missed something. So this is over 4 because you divide it by 3. So this should be, sorry, this is 4. This is 4. Okay, so looking at the previous solution, so 27 divided by 4 x to the 12, which is the same as this, minus 108 divided by 5 x to the 10, so same. Okay, and then we have plus 27 x to the 8, then minus 16 x to the 6 plus 4x to the power 4 plus c. Okay, so this is it. So the same problem solved by different ways, and I hope that you were able to catch up on this class or understand our discussion. Okay, so that's all for today. Thank you very much, and hope to see you again in our next video.